All right, so we're looking at the forward difference here. So we've got our first sheet here about the Olympics, and we've got the number of games here. So the first game was in 1896, and it was in Athens, Greece. The next game was in 1900, and the next game was in 1904. The next game was in 1908. The years till the next game is pretty self-explanatory. So that's 4 to the next game, 4 to the next game, etc., etc. So we want to use that same principle when we come to this number patterns, and we're talking about the forward difference. If we're talking about natural numbers, well, we've got 1, 2, 3, 4, 5, 6, 7. The difference between those numbers is always 1. So natural numbers go up in 1. If we look at even numbers, 2, 4, 6, 8, 10, they go up in 2s. The forward difference is always 2. If we look at odd numbers, 1, 3, 5, 7, the forward difference is always 2. They always go up in 2. Now when we come to square numbers, 1, 4, 9, 16, the forward difference changes. So the difference between 1 and 4 is 3. The difference between 9 and 4 is 5. The difference between 16 and 9 is 7. And because it's a spreadsheet, we can actually use a formula. So the forward difference is actually, it equals that number, whatever's in that cell, minus whatever's in that cell. Okay. And now because it's a formula, the spreadsheet wants to autofill. So we'll take its suggestion. And you can see that with square numbers, that the forward difference is always increasing. What about prime numbers? Well, again, we've got to go through each of the prime numbers. And if we do that same task, so the forward difference equals the difference between that number minus that number, you can see that it actually is not the same the whole time. Whereas the forward difference for square numbers was always going up in 2s, the forward difference for prime numbers is always changing. And then I guess the challenge is to do as many of these sheets as possible. The tuku one, factory patterns, and then graphing each of these algebraic expressions.